what is the purpose? So generally, the control system is a system which output is controlled by the input, by varying the input. Okay, so like let's assume that you have a remote TV and remote. This is also embedded system, right? So whenever you are changing the channel, that will directly affect the TV and it will change the channel. If you press one, it will change the channel one. So like this, it is changing, right? So control system is a system in which output is controlled. How this is the output. So the output is controlled by varying the input. Okay, so input is the remote and output is the channel that you are viewing the screen. So that's how the control system uh, is a system in which the output is controlled by varying the input. And control systems are used in industries. Um, you can write down the control system is a system. Control system, you can write down the heading control system. Control system is a system in which output is controlled by varying the input. Varying the input. Varying the input. Next, control systems are used in industries. You can write down. Okay. So control loop systems are used in industries, whatever the manufacturing at the industry or any equipment industries, we can be everywhere the system we embedded system, it will be plays a major role. Okay, so mainly the purpose is when we are implementing the system should work, it should monitor and it should be controlled. Okay, so that is the main purpose of the control system. And next is whenever we can say the system, so it have a combination of hardware and software. Okay, so hardware is which have to control the output. So who will give the input? So input is the adjustment we are doing. Okay, so and next is the process variables. So like whatever you need to give the information to the controller, so we need to process some variables. So when you process the variables, the output will be varied. Okay, so and moreover, when you give input to the system, so based upon your input, the output will be reacted. Okay, so then it should verify, right? Whatever you are giving the input, sometimes it may not correct also. Okay, so there should be some limitation. So to regulate that system, this control loop system is very useful. Okay, so you can write down the control loop used in the process. Control loop used in the process to control industry. To control industry, all functions in the same manner. All functions in the same manner. Okay, so what are those all functions? We can see there are three activities that can be done. One is measurement, comparison, and adjustment. Okay, so measurement, comparison, adjustment. Clear, right? So now coming to what are the types of control loop system. So here loop is nothing but the system only. Okay, control loop system. There are two types categorized. Control loop, you can write down system. Control system have two types. have two types: open loop control system and closed loop control system. Control system have two types: open loop control system and closed loop control system. Okay, closed loop control system. Next, coming to the open loop control system, write down the open loop control system. We'll give the input to the controller, so our microcontroller. So we are adjusting the values, and because whether it will be computer or anything, so that will be the plant, we can say. So output. So you can write down, like simply you can say the input open loop system and output input and open loop system, input and open loop system, input and open loop system, input action. Okay, this is the open loop system. So we are giving the input to the controller and we are acting it, activating the signal, means we are adjusting the signal from the controller and we are giving the plant. Plant is nothing but here the machinery. Mission, we can say the mission. Mission is anything like like washing machine or the plant, manufacturing plant. Plant means like I need to do some welding, automatic welding. So just you are adjusting the information and then it will do automatic welding. So like you have the packing system also, industrial packing system. So where the packets will be automatically filled and packing. So this is on the part of a plant, you can say. Okay, industry, activating signals and output. This is a output, open loop system. If you're not written, you can write like this: input, open loop system, and output. Okay, so output, whatever that we are getting now, so it won't give that output is correct or not. Okay, so in the open loop system, so whatever we are giving the input, so that will be taken. So means here output, we don't have a feedback, no feedback signal in this system. Okay, so you can write down open loop system, open loop system, open loop system, which controls which controls by varying the output signal, which controls the output by varying the input signal, but don't have feedback signal, don't have feedback signal in the system, don't have feedback in the signal. Next, coming the what are the examples of this is like a washing machine. So what will do, like you can write down, so washing machine, example of open loop system. So we are adjusting, right? Whenever you have a washing machine, so you are setting, okay, I need to rinse it. So just you will say that you will set that and it will start rinsing it. After rinsing, what will happen? It will stop it. So in this system, the operating time is setting manually. So once the time is completed, so whether it is cleaned or not, so it will automatically stop. So here the machine cannot see, okay, the clothes is fully washed. No, it won't see. Just it will complete it process and it will stop it. Okay, the clothes is not still, that dust is there, I need to wash it, do that kind of setting, automatic sensing. So whatever we are setting, it will work and it will stop it. So that is a open loop system. So we are giving the input and it will act it, and it will complete it, and it is stopping it. So that is a what automatic washing machine is a one, and there will be the one like heating of water. So whatever the if you say there is a sensor, so you need to require to heat the water. So that time like just you are inserted the um, heating rod in the water. So just you set it, and it is continuously heated until you end. You like you. Let's take one example as our heater. Okay, like we connect directly to the plug, and we are giving it. So what will happen? It won't have limit, right? It will continuously heating up. Means we set it up as the switch, and it is heating continuously. That is a open loop system. So if it is a closed loop system, when some temperature reaches, it automatically stops. So that is the heater. It will do the closed loop system, but it is a open loop system where it won't stop because the set point is on. So it will keep on continuously controlling. Okay, next write down closed loop control system. Closed loop control system. So closed loop control system. So what will happen is, so here you can write down the block diagram for closed loop system. Input, output, feedback. So this feedback will be the error correction. You can say error connection, error detection. Okay, so what will I will tell you. So this is a control system, closed loop system. It have a feedback that we don't have a feedback for open loop system. Input, output, open loop system. This is a closed loop system. So what is happening is for this error detection is, so whenever you will give the input to the control system, so you will change some values here. So there will be some changing, like it is heated at some temperature. Like if you say it reaches 125 degrees centigrade, what need to do it to the controller should turn off, right? So this feedback will go. So this feedback will say, okay, now you reach at some temperature, you stop it. You don't want to heat. So like this feedback will help you to the information to control this system. Okay, so here we don't have the feedback. So whatever you are feeding, so it will be crosses also no issue. Like it will keep on increasing 126, 130 also. Because here we don't have a feedback. No one will update you that you are making your system heating up. But here, with the help of the feedback, the system can inform you and you will control it. So this is a closed loop system. Is it clear for you all? Open loop system and closed loop system. Okay. So, like whatever the project you still learned, so the PC is the one in the Canoe tool we have, and we have the controller, okay, microcontroller. So whatever you are giving the information from the Canoe, you are directly communicating with the controller. Okay, so this is the open loop system. Open loop system. Okay, so now whatever we have, the other type is closed loop system. That closed loop system is hardware in loop hill. Okay, so what it means? So it have the system. Okay, so means the system PC will be there and controller will be there. So there will be a feedback. Okay, so this feedback will be considered as the closed loop system. Is it clear for you? Now the you need to understand why I am saying this open loop system and closed loop system. This is a concept they will ask you in interview. So like what type of system it is, like whether it is a open loop system or closed loop system, which you work with, and what is the purpose of the system. Okay, is it clear for you all?
Yes, sir. Yes, sir.
Yes. So generally whatever we are giving the input to the closed loop input closed loop system, like input we are giving, and the controller will be there, microcontroller. So it will process the data, and the output signal will be there. From this we are giving the feedback. This will be the output of the processor, so that we are giving again as a feedback to the controller for adjusting the values. Okay, so hope you completed the block diagram for closed loop system, the earlier which I told you. Okay, you can write down this also, like if you need it. Okay, you can write down a closed loop system is a system. Closed loop system is a system in which control action is control action is dependent on the desired output. Control action is dependent. Open loop system is independent. This is a dependent, okay, which control action is dependent on the desired output. Which control action is dependent on the desired output. Okay. So whatever the input you are giving to the system, no? So with the help of the feedback, it will be compared. Okay. So in this system, the output signal is compared with the output signal. You can write on the second point. The output signal is compared with the reference input signal, reference input signal, and error signal is produced. Error signal is produced. Then this error signal is fed to the controller. Error signal is fed to the controller to reduce the error. To reduce the error. Reduce the error. Obtain the desired output. To obtain the desired output. You can write down the same sentence. Okay, is it clear right now? So what are the examples of this? So like automatic electric iron box, like we are using generally, right? So whenever certain temperature reaches, no, automatically it will turn off. Okay, it will be automatically controlled. The iron box which we wait for shut. And moreover, air conditioners. So when we set some point like AC, ACs are ACs in the rooms or offices, automatically it will control or adjust based upon the conditions. Outside it will be 124 degrees centigrade, but inside the house it will be 30 degrees or whatever you are setting it, it will be automatically adjusting it. It is a air conditioner. And even the stabilizer that we used to keep for TVs and all, no, so the stabilizers. So this stabilizer will help whenever there is a fluctuations in the voltages. So this will be automatically adjusted. So how this control loop system it will work? So like when you are setting the input, and we are like input is the sensor. If you say the sensor, we are giving some ranges to the sensor. So whatever the sensor values you are giving, if any calculation is error, so it will be automatically controlled. So then based upon the controlled information, it will be adjusted. So then it will be processed. Then once the process is happened, so it will give the continuous adjustments. Okay, so like setting at some values, so it will be whenever there is a fluctuations is happening, it will be automatically adjusted. Like as I told you, the AC which you set, which we are setting up in the testing. So every box is like partial knowledge is required. So what are the
Andrew, voice is
testing, unit testing, integration
now voice is breaking.
is okay. System testing, acceptance testing. Okay. So other thing is when we come into the control system, So when we work for the project, so there should be a V model, right? In V model, we have the to determine the model in loop. Model in loop is it will verify whether the model is implemented correctly or not. So this is with respect to the MATLAB. Software in loop. Software in loop is where we are checking with respect to the code level. And processor in loop, processor is a hardware, like so controller, you mean to say. So whatever we have the code that will flash into the code ECU, and we are doing a testing. That is a processor in loop. Next is hardware in loop. So it is used for development and testing of the complete control system. So this is the hill we say. Okay, so I will give you the brief notes in further classes. So just a overview. So, and the plant model in loop is something it have the block diagrams that will be the MATLAB Simulink where they are creating the plant model. I have some industry, right? Like where I need to do some process. Like let's take one more example in the car. Okay, car is like it have a 40 controllers. Where 40 controllers at a time I cannot check, right, what are the functionalities, how it is working, how it is working. I need to start engine. I cannot do because I am working for the steering at the others controller. So I need to check only those part, right? Remaining things I cannot check it. So for that purpose, to make the instead of hardware, I need to simulate those features in the simulation way, like how we are making the applications. So similarly, in the MATLAB, we are making such a kind of a blocks. It will be in the plant model, we can say. So in the plant model, I don't have the real engine. So instead of real engine, I have some simulation algorithms will be there. Whenever I will start the engine, so the engine will start running. So that is a simulated way. It is a not fully the hardware. It will be the simulation. Simulation is the physical representation, we can say. Okay, and whatever the model we have, that model will be generated in terms of code, programming, C code. Okay, that C coding will be flashed into the controller. So that will be a processor in loop. So this will be the software in loop. Okay, so this all together, we are interfaced and we are doing a testing as a part of a hardware in loop testing. So those who have a like high experience have working on the model in loop, so they will go with the model loop testing, software in loop testing, and processor in loop testing. As a part of a test engineers, you will doing a part of a hardware in loop testing. Okay, just this is the terminologies you need to just remember or understand the model in loop, software in loop, and processor in loop. So we know about the V model, right, as in the testing process. So whenever we are working for the automotive vehicles, so like whenever you are getting the requirements, so you will always check with the ISO standard like a 262 whether it is a safety requirements or any regulations or rules and regulations is violating or not. So when you are taking the requirement, you will consider those all the factors. Okay, so whatever the requirements you are getting, there are some tools we have. That is a doors, prevision, ECU, car, BEP, ISO, VDA. There are some tools, like all the tools and standards, all will be verified when you are getting the requirement. And moreover, once you got the requirement, you will go with the design of the architect, like the requirement. So the high level design you will do, then the low level design we will do, then you will do the coding. So then you will validate with respect to the coding, and you will do the unit testing and the integration testing. So then will be the you are doing some process related to the software things. You will do these tools, trace32, PVC, code barrier. These are for software implementation and doing. And for this design, the code, rapid prototype, Simulink, these are the some tools we required for understanding. Okay, so we model. So let's take to understand of the what is a plant model here. So what is a hill? So whenever plant is say, suppose if you say there is a switches, so here you have the component, right? So for this, this is the steering, okay, steering component, steering and wheels alignment it is, okay. So for this, what how you need to verify as an engineer? So you will take like one box setup. So in box setup, you have all the sensors, okay. The sensor signals will be there. How that sensor signals will be controlled is with the help of the model. So with the help of the model, we are controlling the sensors. So now controlling the sensors is fine, but how the software will flow? So whatever the software we are developers they are doing, that will be there in the controller. So that controller information is giving to the hill PC. So then you are working like so you are giving the input from the controller. So means you will turn on the engine, turning on the steering, so that all information you are giving for this. So let's this will be little bit understanding of about vehicle testing. So vehicle testing, it have the sensors. So sensors will give the information to the controller. The controller will send the output to the actuator. So that is a vehicle test you will do on the real time on vehicle. And this is a simulator. So simulator means like you don't it will be a part of the controller ECU. So it is directly connected to the hill bench. Hill bench is hardware in loop bench. It have all the controllers and feedback mechanism. Okay. So this will be controlled directly. So this is about the hill system simulation testing, vehicle testing. So we discussed about the closed loop system and open loop system as well. Okay, so like closed loop systems, we are testing in navigation control and flight control, and in our automotive vehicle and some of the stream and turbine controls, medical devices and printers. So even the dryer controller, so the washing machine we can say. So because there are advanced, like this is automatically setted and it will wash and it will give you, it will adjusting of the system. And this is a more detail about the control system and open loop system. So here open loop and closed loop system, so the feedback is absent, and closed loop system we have a feedback. So error detection is not present. Error detection is always present in the closed loop system. This is a stable one. This is unstable because whatever the feedback you have, so it keep on updates you based upon the input. Here whatever you are giving input, it will be stable. It is easy to construct, it is a difficult, and it is a costlier closed loop, it is a not much. And having a small bandwidth, it have a large bandwidth. It is we are getting accurate because based upon the input, output will be very bit, it will be accurate. Okay, so those are the examples we discussed. Like a open loop system is T maker and hand dryer, and closed loop system is a less voltage supplier on some of this. Okay, so even some of the examples of the motor open loop system. So open loop system is like we have the antenna and the motor and the amplifiers. So amplifier, we are giving the input to the motor and to the antenna. Here we don't have any mechanism. This is a direct connection. And so here we have a feedback because the feedback is a potentiometer. We are not given directly to the motor. So we have a other connection, the potentiometer. So we have adjusted with it, the closed loop system. This is the feedback. So where it will be automatically adjusted from the potentiometer, and the difference, any differences is there. So it will be automatically set up. Means make it will give a clear understanding of this complete system.